First thing is, I'm going to solve a simpler problem to start with. Here, right now, I'm returning the empty list. I'm saying no matter what values you give me, none of them were positive. That's the wrong answer, right? Let's try a different wrong answer. What if I decide that every number is positive? I just want to return a copy of the input. And then I'll worry about how I make the decision. Okay? So, I could say n equals 0, while n is less than the length of values, result.append of values n, and then move n on. And of course, I'm going to need to start result as an empty list so that I've got something to append to. Now notice what I did. I wrote the body of the loop. I said result.append. Oh, right. I better go back and make sure there's an empty list. That was my thought process. How am I solving it? What am I assuming already exists? Now, if I run this, of course, it's still going to fail. Because in the case where some of the values are non-positive, this should just be returning a copy of the input. Okay. So I now want to add a little bit of logic so that I'm not always putting the value on the end of result. Before I do that, though, remember we looked at for loops? This loop here, the while loop, has three parts. Initialize the index, test to see if we're done, move the index on. 3/4 of the time, roughly, and there are big error bars around this, you don't care whether you are at location 5 or 15 or 55 in a particular list. You just want to know what's the next value. As long as you can get them in order, you can process them. And that's what the for loop is there for. So let's do this. For v in values, results.append v. What the for loop does in Python, and new style for loops in Java, you'll see these in other languages now, is say, I want to walk through the list v, just give me the values in order so I can deal with them one by one. I don't care whether I'm at location 5, 15, or 55, I just want the next value. So, that for loop keeps track of where it is in the list. It assigns the 0th element to v, you do something with that. It assigns the first element to v, you do something with that. It assigns the second element to v, the third, the fourth, and so on. And you can do anything in here you want. V equals minus 1, 2, 3, 4. It doesn't affect what happens up here when we reset. Any changes you make in here to v get overwritten when we come back up to the top of the loop. The loop will always keep track of where it is in the list and just keep assigning the next value from the list to v at this point. Okay. The thing you don't want to do, unless you're really sure you understand what's going on, is change the list values while you're looping over it. I'm keeping track of where I am. Imagine you're all queued up and I am supposed to, collect some information from you. If you people drop out of the queue and then add yourselves back in, I might miss some of you or count you twice. Similarly, if inside the body of this loop I'm modifying that list values, the for loop might lose track of where it is. The rule for exactly what it does and how it does, if values is changing, is perfectly well defined, but it's not simple. So, good rule of thumb, unless you are this tall, old enough to go drinking on your own in Germany, don't mess with the thing that you're looping over. Because even if you get it right, the next person to read your code might not understand it. If I'm going to do something for everybody in this room, I would like you to sit still while I'm going through it, because if you're all up and milling about, it's just making my life a lot harder. Okay, so now I've got some code that will just copy everything from values onto result. Now this is a slightly more useful function, the one that just always returns an empty list. It's still wrong, but at least I've solved half my problem. I'm looking at these values one by one. So now I'm going to come in and modify this to say, if v is greater than 0, then append it. There's an obvious logical place to put the test. Instead of just appending it, I say, if you're the thing I want, then append. All right? How many people believe that this code is correct? Okay. We're not going to throw... I got a yellow card. Good. Okay, 2 yellow cards. Oh, no. Just show me some cards. If you're sure it's wrong, red card. If you're absolutely willing to put the kitten's life at risk, okay, I want a green card. If you're cautious but you're not sure why, you've just got that sort of feeling in your stomach, yellow card. I'm seeing a bunch of yellow cards. No green cards. Green card. 2 greens. What's up? 3 greens, 4 greens, 5 greens, and some yellows. 1 red card. Oh, okay, what's wrong with this function? Okay, slow down and say again, I'm sorry.
If the values is not some number, it's some string.
Okay, good point. What if this is a list of strings? What if this is a list that has a mixture of integers and strings? How paranoid should I be? No, it's a good question. I can spend a lot of time checking for things and writing code to check for things that just don't matter in practice. How do I tell which ones to check for? There is a story James Bach tells of spending a year at Intel building a testing framework that would take all of the tests they wanted to run, several thousand tests, each of which took several minutes, and it would farm them out on the available workstations and run the tests and collect the results. And if a workstation got rebooted or failed during a test, it would automatically detect that and restart. They spent a year working on this framework. In the year that they kept it running, it found 2 bugs that had not been found by other testing. It was not cost effective to put that much effort into the test framework. And so you have to think about testing in terms of economics. Okay? Is it worth in here doing a sweep over values to make sure that they are all numbers or integers before I start to do this? Can I just put a test in here to say, assert that v is an integer and if not blow up because I'm only supposed to work for integers? Or should I just leave it up to my caller and say, you please make sure this is data? Now, in a language like Java, I would have to declare the type of this. I would have to say this is a list of integers. That's useful. If I say here it's a list of integers and anybody ever tries to write code that calls it with a list of strings or some other data structure, the compiler will just say, no, this couldn't possibly work. I've provided more information about the constraints so the program can be checked even before it runs. Okay? That's a good thing, but now I can't use this function for a list of real numbers. It only works for a list of integers. Okay? And it's kind of annoying to me that I can use this to find all the positive integers, but then I have to write another function if I want to find all the positive floating point numbers. Right? That kind of seems silly. Right? So there's a trade-off. And again, it's a strict engineering trade-off. Trade-off number 1 is the economics of testing. How much effort do I put into being paranoid as opposed to just trusting myself to catch it when it does go wrong and notice it? Okay? I could always be a little bit more paranoid. Right? I mean, I'm from North America. I could always be a little bit more paranoid. Right? Alternatively, do I want to pick a language that puts really tight constraints on what I do so it can check everything up front? Do I want a language which just says, dude, good luck? Right? Do I want something in between? Again, it's an engineering trade-off. The smaller your program, the more likely you are to just type in a few commands interactively. You don't want to have to say, when you're typing at the command prompt, this is a non-empty list of integers. You just want to say, look, it's values. I'm writing a 4-line function. Right? The temptation, of course, is to take the things that work on a small scale when you're just typing stuff in, and it grows and grows and grows, and now it's 100,000 lines of code, and all the checks that you want to have on a big engineering project aren't in the language you picked back when this was just you. Okay? So, let's give it a try.